Oh, hello everyone. Good afternoon. Hello, good afternoon. So, I hope you must be excited to learn something about ZIO, right? Okay, so welcome to the CodeChef ICO Learning Program. This is specifically a combinatorics mod. This is the first lecture of the combinatorics module for ZIO preparation uh, under the name ICO Learning Series. Okay, and right. So, first, a brief introduction. This may be a bit repetitive for someone, but okay, but I promise, it will be very useful for others. The course and lecture, this will be the first lecture in the Combinatorics module under the ICO Learning Program run by CodeChef and An Academy. Zonal Informatics Olympiad is the first stage of the Computing Olympiad program in India and has four problems to be solved in 3 hours format. There are three parts to each problem, right? And the problems are mostly based on algorithmic thinking and informatics, and they are based on intuition. And the next step is to sit for INOI, National Olympiad in Informatics. About me, I'm a second year undergraduate math and computer science student at Chennai Mathematical Institute, and I'm from West Bengal. I've cleared regional math Olympiads. Hmm, uh, is there a audio lag in everybody's case? Okay, I've qualified some regional math Olympiads and informatics, and also have some experience from math camps, and I've also been a student and a counselor. Okay, at Promise. Okay, and I hope I will be able to guide you properly so that you learn combinatorics well to prepare for ZIO this year. Okay, I think some are facing audio. I'm not sure. Okay, anyway, let's continue. Right. So, what do I expect you to know? The prerequisites would be that I expect that you know some set theoretic concepts like what is the meaning of intersection, what is the meaning of union, subsets, disjoint sets, etc. I expect that you understand basic arithmetic, addition, multiplication, subtraction, division, and I also expect that you understand some basic modular arithmetic. If not modular arithmetic, then at least I expect that you understand what is division uh, in integers. That's enough. And right, we will cover some theory here, and we will understand them even better through some concrete examples. I'll show you a couple of solutions of those examples, but there will be some which you will solve and I'll guide you through them. And after the session you can ask your questions, and the only thing that I expect from you is that you are lively and you are interactive and you join me in this session. And please, if you have a question, ask immediately. Hope you enjoy this. Okay, let's see what we are going to learn today and outline. So when do we add? Okay, some people are having audio problems. I'm not sure if it's persistent with everybody. Hmm. Okay, if there are some, all right, I will continue. So when do we add? So what do we do in combinatorics? Combinatorics is mostly counting. There are other aspects as well, existential problems, but okay, what we count. When do we want to sum to integers? So we don't want to merely count, or we don't want to merely multiply. We want to give some proper meaning to them. Like we expect to daily objects like maybe say mobile phones, maybe cars, balls, sticks, etc., and give meaning, and we want to understand what is the meaning of addition and multiplication, and via our intuition we want to decide that when do we want to add and multiply while counting. Okay, so while counting, if you have two apples, what you are doing is you are taking one apple and then adding another, so it's two. So something like that. So we want to distinguish that when do we want to add and when do we want to multiply. And coming to the technical parts, when do we want to rearrange letters and want to find how many ways are there, or we'll see what kind of analysis we want to do, right? Then once we have some formula in our hand for rearranging letters, I also want to take you back to the first principles, because the first principles are your only true friends. Your formulae won't help you everywhere, but your first principles will help you each and everywhere. And then what it means to choose. What is choosing? Where order doesn't matter. So in rearranging letters, in this third point, we are considering the order, but there we are also interested in what happens when we want to just choose without the order. And then we give you introduction to some combinatorial objects, but without knowing their numerical value, right? So that you can use them, and maybe when you want to compute, you will get to know the numerical value later and you use them there. But you first need to understand well how to use the combinatorial to solve problems. But there is a final warning, because this is mostly a problem oriented subject. So there are some things to take care about, right? And over here we learn the techniques of counting, some standard objects which are useful in problem solving. The focus is to develop a mindset in thinking in terms of daily objects, and not really just math, or not really just numbers or just algebra. We need to think in terms of building. Okay, all right. So we start with our first topic. When do we add? Okay, so this is precisely the addition principle which is said in combinatorics, right? So when do we add? It's said that if you have a finite set S, and you can partition this. So partition, I'll explain what partition is, into distinct components. Those partitions build up S completely. So what do I mean? So this is your S. Partition means you break it into components so that they don't interact with each other. So maybe say this is your first component, this is your second component, this is your third, and this is your fourth component. So these are four partitions of the set S. So this is your total set S, and you divide the objects into these four regions. So what do we say? We write S is equal to union, okay, S1, union S2, union S3, union S4. Okay, and what happens if you have the disjoint components? So the total objects in S, each object has to be in exactly one of these four. So what is the cardinality of S? Cardinality means number of objects in S, right? So it is what? Number of objects in S1, number of objects in S2, right? Number of objects in S3, and number of objects in S4. Okay? Because every object must belong to one of these sets and exactly one of these sets, right? Yeah, now is better. So this is how you count. Okay. I'll tell you how to use this. Maybe let's take an example. So these are the collection of some of my pens that I had. So what I will do is, this is the set of the pens that I have. Okay, this entire thing is S. Let me write it with red. Yeah, this entire thing is S. Okay, what is the meaning of that? That means, this means, let's go back to the previous slide. So this means cardinality, number of objects in the set S. Okay, so this is my set S, all of these pens. How many of them are there? 9 in total. All right. So what I do is, I partition them into colors, according to colors. So this is my first set. I have another set like this. Okay. My third set could be these. So comprising these. And my last set is this. Okay. This color is not so visible, but okay. Yeah. So what is my, okay. So there are, so this is say 1. This is S1. This is S2. This is say S3. And this is say S4. Okay, there are 9 pencil all. So you have 9, but you can write these 9 pens something like, so what is 1? So what is cardinality of S1? It is 2. What is cardinality of S2? It is 4. Cardinality of S3 is 2 again. Cardinality S4 is 1. So this is not just merely 9 is equal to 2, 4, 2, 1. It is, so these numbers 2, 4, 2 and 1, they kind of tell you the structure of these sets. So there are 2 objects in the first set, 4 objects in the second set, and so on. Let's take another example, right? Okay. So we have the numbers 1 to 15. I have written it in this order. Right? Yeah, these slides will be uploaded. You will be having these slides. So what I do is that I will group these numbers according to the remainder they leave when divided by 4. Okay. So going modulo 4 means take a number. What is the remainder it leaves when you divide by 4? Okay. So notice that the numbers 1, 5, 9 and 13, all of them leave a remainder of 1 when divided by 4. So I put them in one group. Maybe label it as 1. All these numbers leave a remainder of 2. All these numbers leave a remainder of 3. They leave a remainder of 0. Okay. So what this means is that I have partitioned this 15 into 4 sets. What are the 4 sets? The 4 sets are, it is 1 plus, sorry, so cardinality, so I don't mean to write 1 plus 2. I mean to write, so there are 4 in the first, 4 in the second, 4 in the third, and this 0th guy, there are 3 of them. All right. Right. Now, what we have is another example. Okay. So you consider the numbers 1 to 5. How many we take 2 distinct numbers from A? Okay. Right. How many ways are there? Now, so mathematically, we model this question that we want to find the cardinality of the set S, where S is equal to all the subsets of length 2, that is x comma y, such that x and y come from A and they are distinct, right? Okay, so let's see. Someone, okay, what are your, so someone has told me it is 5 into 4. Okay, can others also guess what is the answer? I can help you in your comments. Okay, okay, I haven't defined what is C yet, so I don't know what is C. Okay, someone has said 60, someone has said 20. All right, let's see what we get. In generality, okay, so if you have a word where there are m1 many letters of this l1 kind, m2 many letters of this m2 kind, and so on. Okay, so over in the first example there were 2 letters a and 2 letters b, right? What happens? The number of permutations of w of this word is exactly what you permute the total thing. Okay, so think of it like this. Hide this part first. Hide this. Okay, hide this. First, look at the total number of permutations. That is the length of the word factorial. But you have repetitions because you don't want to interchange those A's together with itself. They are the same. They look the same. They are the same. So, what you can think of it as, you divide by the number of permutations of this part, because you want to remove this part. So if you want to remove this, you divide. Okay, if you and you want to remove this part, so you divide by another m2 factorial, and dot dot dot, you want to remove this part, so all the way up to mk factorial. All right, now let's come back to the first principles. Okay, how many squares can you find in a 4x4 chessboard? Okay, I will give you options. So, okay, by square side, okay, this is also a square. This is also a square. Okay, now this is also a square. So like this, how many squares can you find? Again, this is a square. This entire big thing is one single square. Okay, so how many squares can you find? Okay, I will give you options. Options are 30, 20. Nah, never mind. I won't give you options. Hold on. Okay, so 30, 20, right. 30, 20, 25, and 36. And the, okay, this is A, this is B, this is C, this is D, this is E, and another option is 16. Okay, so I will give you options. So I'll give you 45 seconds and you start. Okay, choose. Interesting. Okay, poll has ended. 50% have answered. Okay, 45% have answered this. Okay, this is indeed the correct answer. Some of you have answered 25, some of you have answered 36 and 16 as well. So I will let's discuss. This is a very interesting question. This is a very interesting problem. Okay. So what I do is that if for so a typical square looks like this. Okay, what I do is extend this and this and this and this. So what I now have is something like, okay, and think of these as sticks. So if I have placed my stick in this way, you can think that this is my square that I need. This is my square region that I need. Okay. Now let's do a blue thing. Okay, for a blue square. So if I have placed my sticks, maybe say something like this between the blue sticks, then my required square is this. Okay, this is my required square. All right. So it boils down to you fix a distance or you fix a length or you fix a side of a square. So L is the side of the square. That is the distance between the two sticks. Okay. Over here and over here, and then you decide that fixing the length, how many possible positions are there for the square. Okay, so if the length is 1, okay, you can either place your stick here, or you can place your stick here, or you can place your stick here, or you can place your stick here. So for the vertical sticks, there are 4 choices. For the horizontal sticks, how many choices are there? There are 4 choices. Okay. And why do we multiply these? Because for each position of the vertical stick, for each vertical position, I can move the horizontal guys. Okay. Now for L equals to 2, how many positions for the horizontal? How many positions there are? No. Okay. Let's see. How many positions for the horizontal? Okay. Someone says 3. So I can either place my stick over here, or I can place it over like this, or I can place it like this. So 3 ways. So 3, and same for the horizontal ones. Now for L equals to 3, there is how many options? 2 squared option, because I can either place it okay, 2 squared options, because I can either place it like this or I can place it like this, and same for the horizontal. And now if I have L equals to 4, I have maybe how many options? Right, 1 squared option. So total is 1 squared plus 2 squared plus 3 squared plus 4 squared, which is, if you calculate this, it comes out to be 30. All right. Okay, good. Now, okay, now one natural question to ask is that what happens if you consider this, instead of 4 by 4, you consider n by n. Can someone guess what will be the answer if it is n by n? By the same logic. Okay, so you know the formula. Okay, someone says sum of squares till n. Yes, by the same logic, it will be 1 squared plus 2 squared all the way up to n squared. Okay. Yes. Yes. Good. Good. Yes, all squares, the sum of squares from 1 to n. Okay. Now we come to another question, that how many subsets of n are there? Okay. Now, for this, we delve deeper into how a subset is made. How is a subset made? So, if you have a set S, which is a subset of this, okay. Now, 1, how do you know 1 is present or not? You don't know, right? So, 1 can either be present or absent. For 2, 2 can either be present or absent. And same for everything. Everything is either present or absent. Okay, what does it mean present or absent? It means that for 1 I have 2 choices, either present or absent. So you pick either of the two choices. For 2 there is 2 choices, either present or absent. You pick either of the two. Okay. For n also you have 2 choices. Now the important part is that if you have 2, for each choice of 1, you have to choose 2. Like you have to choose something for 2 for each choice of 1. So it is connected via the conjunction AND. Okay. Again, for each of these academy, right? Am I connected right now? Yeah. Okay. Good. So this is for this. All of these are connected via this AND conjunction. So it is 2 multiplied by 2 multiplied by all the way up to 2 and n times, which is 2 raised to the power of n. Okay. So there are 2 raised to the power of n many subsets. All right. Is this clear? Hmm. Um, okay, I shall explain once more. So what you have is that this element 1 is either present in S or it is absent. So for the element 1, okay, this is the element 1, this is the object 1, okay. For this object, there are 2 choices, that it is either in a subset or it is not. So it is asking that how many subsets are there of this given set. You have this set 1 to n, and how many subsets are there? Okay. So it is either there or it is not there. Okay. If it is there, so 2 choices. If it is either there or not. Okay. Now for each of these choices, you have to choose some. You have to make a choice for the element 2. This is the element 2. Okay. This thing is the element 2. For each of the choice of 1, you have to choose something for 2. Now for each of those choices, you have to choose something for 3. And so on. Each of the choices for 1 to n minus 1, you have to choose something for the last element n. This is 2. Yes, the subset can be of any size. I am just asking that it is a subset. Okay. So there are 2 and they are connected via the AND conjunction. So 2 into 2 into 2 all the way up to n. Right? Okay. Now we talk about another combinatorial object. I will not give you the count, but what is it? So we are interested in looking at uh, the number of ways to just choose. Okay, you have a bag, you put your hand in the bag, you have a bag of n balls. They are all different balls. You put your hand inside the bag, you pick out R balls. You can feel, you can count that, yeah, these are the R balls. In your one hand, yeah, I can say, yeah, R balls, pick them out. How many possibilities are there? That is what I am asking. So as an example, let us see. So if you have one, so inside this bag, you have this blue ball, you have this green ball, and you have this pink ball. And I am asking that how many ways are there that you can choose, that you put your hand in this bag and you pick out 2 balls. Okay. So it can either happen that the balls you have picked are either this green and pink. it can happen that the balls you have picked are this green and blue, or it can happen that the balls are blue and pink. Okay, right there. So our answer in this case would be 3. And what do we denote this by? So this thing, this over here, make it here. We are denoting this thing by a notation. I'm not telling you how much it is, but I'm saying that if you are to choose R objects from N objects, the notation is something like this. I will just denote it by this, or some people denote it by this. Okay, I will just denote it. I don't know how many this is still as of now. Some of you are writing. Okay, for now I don't know, but I will make use of this in my combinatorics. How? Let's see. So over here, what did we see? We saw that? What did we see? What is the value of 3? Choose 2. What is this? Someone tell me. What did we see from this example? So from 3, if I want to pick 2 objects, I can either have this or this. Okay. So what is this? What is 3C2 or 3C2? What is it? Maybe write in the comments. Okay, 3. Right, this is 3. Yeah, good. Because we have seen that it can either be this or this or this. Right. Now let's take a look at a problem where we will standing so far. Okay. Okay. So 10 cell phones. For every day at work, he takes 2 of them to his office or to his work, wherever he goes. And he works for 25 days in a month. How many possible phone combinations? Yeah, this guy is a very rich guy. In fact, he's so rich that he takes 2 phones to work and he has like 10 options to choose from. Okay. So, yeah, how many options does he have? So, as the old proverb goes, beggars can't be choosers. He has a lot of choices, so he's not a beggar. He's very rich. Right. Okay, now let's see what can we do. So for these 25 days, okay, let's see, let's write in English. So choose on, so I will write D, not this. I will write, so choose 2 phones on day 1. I'm writing this for myself and for you guys also. Also, I have to choose 2 phones on D2. I have to choose 2 phones on D3. Okay. All the way up to I have to choose 2 phones on day 25. Okay. Now this is not a complete English sentence. I have to join these with something. I have to join. So these are clauses, right? This is one part, this is one part, this is one part. Okay. I have to join with clauses. So what? I have to join with conjunction. So I have to join with and or. Should I use and or should I use or? Okay, I'll conduct a poll. And option A is and, option B is or. Okay, so let's see. There will be 4 options, but you choose either A or B. Okay. Yeah, so you choose either A or B. There will be 45 seconds. What should I choose? And or or? 30 seconds remaining. So how should I join the parts of these sentences? So should I say choose 2 phones on day 1 or choose 2 phones on day 2, etc.? Or should I say choose 2 phones on day 1 and choose 2 phones on day 2, etc.? All right. So 75% of you have chosen and that is what we go for. We choose and. Okay. Right. Now let's see. So he picks 2 phones for the first day and 2 phones for the second day. And so on until he chooses 2 phones for the 25th day. Okay. Now, how many choices are there for each day? So, for consider one single day. Break it up into one single day. Look at it here. Okay. So, what do? I have told you just now that if you have 10 objects and you want to put your hand inside and pick out 2 of them. Is what? 10 choose 2, right? 10 choose 2 for one day, each day. Now each day it is connected with and conjunction. So 10 choose 2 and that is multiply, 10 choose 2 multiply, 10 choose 2. So this is what I was referring to when I meant last that you convert it into English and then replace all the ands with multiplication, etc. Alright. So this is basically 10 choose 2 raised to the 25. Okay. I hope this example makes my standing clear that what I mean when I say that you need to use that trick, changing into English and making it yourself. Okay. All right. Okay. So now we come to our last problem. This is a very crucial problem in some sense because I want to deliver a message through this. A small message. Okay. So I say that 2n players participate in a tennis tournament. Okay, in a tennis tournament, for the first round itself, I need to break the players into pairs of 2. So I have 2n players. So out of that I pick 2, they play. Out of the remaining, I pick another 2, they play. Then I picked another 2, they play. Okay, and so on. I continue. And it's not like that. The first pair that I chose that has pair because all of them are competing simultaneously. Okay. Now, what I'm saying, so it is not only 2 and choose 2. I'm not choosing 2 players out of this, out of the 2n players. I'm taking 2 players, but I want to take more 2. I want to take more 2. I want to take more 2. And I have these pairings over here with me. Okay. So let me illustrate. I have this. These are my players. I take 2 of them. I take 2 of them. I take 2 of them. I take 2 of them until all of them are exhausted. So is the problem clear? No, let's not go back to the answer. Let's question about the question. Let's understand the question very well. I think it is clear almost. Okay. 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 If the question is clear, now I give you 2 minutes to think. So give me some. Okay. Someone asked me to re-explain, right? Sure, I will re-explain. So you have these 2n play. Okay. Let me say I have the 4, 5 and 6. So 6 players I have. Want to make pairs out of them so that they can play their matches. Only in the first round. Okay. So suppose I make a pair something like this. So these 2 play against each other. These 2 play against each other and these 2 play against each other. Yeah, okay. So how many ways can the matching be done? That is my question. Um, okay, someone says n, but I just told you that you need to pick two. So there has to be something about choice. Uh, Tejas has said 2n factorial by 2 factorial power n. Okay, no Tejas. Okay, 2n C2. Akash has said 2n C2. Okay, Set has said NC2 n minus. Okay, why is it NC2? I have 2n players, right? So it should be 2nC2. Okay, Abhinav Kumar, I think he has said a good answer. Okay, I'm seeing some nice responses from you guys. Okay, let's see. Let's see. So, okay. So, what we are doing here? So, I have 2n players. I choose two. I pick out two of them. But now I need to pair more. I have paired two people. Okay, two people are fine. But what about the 2n minus 2 remaining people? So, 2n minus 2, choose 2. Okay, I have made one pair, I have made another pair. There are 2n minus 4 people remain. What about them? I do it again. 2n minus 4, choose 2. And I shall continue this all the way up to 2, choose 2. Okay. Now, if you guys know the formula of n choose r, you guys can figure out how to simplify this. Okay. Now, I have a very important question. Okay. So sometimes it can seem that a combinatorial argument is correct, but it may not be correct. Okay. So I am asking you, is this answer presented in front of you, is this correct? I will conduct a poll. Okay, I'll conduct a poll. If this answer is correct, vote for true. If this answer is wrong, vote for false. You will have 45 seconds. Okay. So is this answer in front of you true or false? So poll has started, 45 seconds. Is this answer in front of you true or false? Okay, I think we have a very interesting competition here. Very, very interesting competition. Let me share. So, okay, right. Okay, now the thing is that all 53% voted that this is true. So I'll write in green. 53% voted for true, and the other 47% voted for false. This is a very tough competition. Who should win? Who do you think should win? Okay, 47% of the people think that 47% should win, and 53% of the people think that 53% should win. My winner is this. Okay, why did I say 47% wins? A minority wins over here. Okay, so what is it? So when I'm choosing two players, I'm saying that choose the two players. So first, so in my subconscious head, what did I say? I said that no, the correct answer wasn't displayed. I did not select the answer. Yeah, so what did I do? So in my head, I'm saying that first choose two players. Out of the remaining, the second pair is 2n, choose 2n minus 2, choose 2. The third pair is 2n minus 4, choose 2. So what have we done? When we are counting, we are saying first pair, second pair, third pair, etc. We don't want first, second, third. All of them are on equal standing. Nothing is first, second, third. So if you recall from the formula I gave you for permutation with repetition, it's similar that in order to remove all of those n standings, first, second, third, I don't want those n standings. I want to remove the permutation of the n arrangements, the n objects. I don't want the permutation. So I want to remove them. What do I do in order to remove them? I divide by n factorial. So this is the correct answer. So this is a word of caution, that a very important word of caution in combinatorics, that we often introduce order while making the combinatorial arguments without even realizing that we are ordering them. We are putting an order. We are subconsciously putting an order, but we don't realize. So please be very careful. So in the BBAA example also, the one example we saw was the last one, and the BBAA example, over there, we could say something like take the left wala B and place it here and do something with the other B. Again over there, if we say the left B, we are saying that take this B, we are distinguishing this B. Okay, we are distinguishing this B. We should not distinguish this. So please be very careful. Okay. So Sudhira has asked me to explain again. So what I wanted to explain is that be very careful when you are making arguments like this, because when I'm saying that I'm picking two pairs first, two players for the first pair, then out of the remaining, the second pair is this choose 2. The third pair is 2 and minus 4, choose 2. Okay, so this introduces one ordering. What kind of ordering? This is the first pair, this is the second pair, and so on. So I want to divide it by n factorial because I want to remove the n factorial orderings. Okay, you can expand this if you know the formula. And so I'm asking you to be very confident, be very careful about this. But there is a thing that you can do. So there is a way out. What is the way out? Can someone guess what is the way out so that you can avoid this? Okay, people are thinking the way out is to practice, practice, and practice. Right. Okay, so practice a lot. Okay, that's my suggestion. Okay, check for smaller values of n also, but in general, if you want, yeah, even smaller values of n can give you some sort of, yeah. And then, so from this session, whatever you have over here, so I'd like to end this session in a couple of minutes, right? And whatever we have seen in this session, you can practice the current problem set on Unacademy. So everything over there can be solved using whatever I have taught here. Okay. And so you can contact me. This is incorrect. This is incorrect. Sorry. This part. Okay. So on Discord, I am Luida. And my nickname is Nilava Metya on the server. Yeah, okay. This had a general lag. I'm sorry. It was my internet to some extent, to a great extent, I would say. Okay. And also, please fill up the feedback form. Yeah. So some people are confused. What is the confusion? Okay. Oh. Okay. So I think I want to end this here. If you want, you can ask questions. I can extend this session by say 10 minutes or so. Okay, if so I this PDF will be available to you. Okay, if you want to ask, you can ask. I'm here for another 10 minutes or so. RMO versus ZIO. I have experience in both RMO and ZIO. So in ZIO, it's mostly computational. You can hand wave your combinatorial arguments in ZIO, but in RMO, you have to be very precise and to the point. So this answers Rito Saha's question. Yes, so in ZIO, you can hand wave your arguments because you are just talking to yourself. They just need the answer. Yeah, that's it. I don't think there is any unacademy group. There is a Discord group though. In ZIO, that most of the problems belongs. Yes, in ZIO, it's informatics, and yes, most of the problems are from ZIO and combinatorics. So combinatorics is mostly counting, and DP is also a very important part. Okay. How do you join that Discord group? So you need to have registered for ZIO to join that Discord group. How you ever qualified ZIO? I don't get the question. I'm sorry. Hmm. Yes, I have when I was in 10th grade, 11th grade, and 12th grade. Yes, if you want, you can leave. Sure, I don't have any problem. Okay, book suggestion I will give you later. As of now, you can take Richard Brualdi for theory, and for practice problems, ZIO past papers and solving strategies. Only the beginning part, very beginning part, because it's a very hard book. By more classes, okay? Book suggestions. Someone was asking for book suggestions. Yeah, past papers. Past paper important for ZIU. Even if they're as old as 2002 or 3. Even if they're as old as 2002 or 3. Um, so my code forces handle, I don't use on code force. I don't use code forces. I don't even remember my handle. Okay, maybe I'll share in some other slide after I check. No, all combinatorics problems cannot be solved using DP. I don't think everything can be solved using. Okay, in some sense, they are DP. If you consider that finding max is also a DP, okay, then sure. Okay, I take my statement. Okay, finding max is a DP because you find the max till n elements, and the max of the n plus 1 elements will be max so far current maximum, and the last maximum uska max. Uh, I think there are not many more questions. Are there any more? Okay, if there are no more questions, please fill the feedback form. And thank you. This has been a very great audience to me. And I'll see you in the further 2 sessions.